Hello. For my digital article, I want to talk about a very specific topic, which is carbon emissions by cement sector in India. For context, I want to describe the city I'm from, which is Mumbai. Mumbai is one of the biggest cities in India and also known as its economic hub. Its population has grown tremendously in the past 2 decades, which is mostly fueled by rapid rural to urban migration. Its built environment has seen a significant change with land reclamation projects, bridges, and a multitude of skyscrapers. The environment impact because of this is quite tangible, with loss of green spaces, unprecedented flooding, and rising sea levels. As an engineer working in the building sector, I believe I have a more direct impact on this. This presentation, however, is about a construction material called concrete, which represents the most silent kind of danger of economic growth. Now, concrete or cement is the second most consumed substance in the planet, second only to water. It's a bedrock of economic and infrastructure growth. About 4 billion tons of it was produced in 2023. For reference, just 1.4 billion tons was produced back in 1995. This is expected to grow to 5.5 billion tons by 2050. It's critical to note that concrete production has resulted in almost 8% of the worldwide greenhouse gas emissions. Hence, it's imperative to understand and find steps to mitigate these emissions. Concrete is a mixture of constituent elements like sand and stones, which is binded together by an element called cement. Now, cement is what's responsible for the emissions. For every kg of cement produced, almost zero point 0.6 kg of CO2 is released into the atmosphere. This graph represents a rising trend of CO2 emissions because of production of cement. About 1.6 billion tons of CO2 was released in 2022 because of production of cement. We'll look at India's role in this. India is the second largest manufacturer of cement following China. What's concerning is that almost 50% of the infrastructure growth needed to be built by 2050 hasn't been built yet. So the demand for cement is only expected to grow. About 375 million tons of cement was produced in the country in 2023 and is projected to grow to 660 million by 2030. The production capacity, however, is much higher at almost 4 to 5 billion. We will dive a bit deeper into the mechanism behind cement production. Naturally occurring limestone is heated in cylindrical steel containers called kilns to a very high temperature, which is then converted to lime or cement clinkers. Almost all the greenhouse gas emitter is CO2, as seen from this chemical reaction here. 50% of the overall CO2 comes from this chemical reaction, and the remaining 50% is because of the energy requirement to enable this reaction process. This comes mainly from electricity and other sources of fuels. Identifying this problem, Center for Science and Environment India has laid a roadmap towards mitigation. In this graph, we see various emission scenarios for this sector by 2030. Business as usual scenario would result in almost twice the current emissions. But following appropriate steps and strategies, this rise can be contained as seen from this last bar graph. Decarbonization can be classified into four broad areas. Adopting energy efficient processes during manufacturing, trying to recover waste heat along each step of the manufacturing process, using alternative fuels such as biomass and municipal solid waste, and in general trying to transition into more renewable sources of energy. Clinker factor reduction deals with the chemistry of the material. We'll look at this in the next slide. Finally, carbon management using technologies such as carbon capture. Government can provide incentives to companies trying to adopt decarbonization policies. There are four major types of cement produced in the country. The numbers in black here indicate the potential of carbon emissions. More the carbon emitting potential, more the amount of limestone or clinker present in that particular type of cement. This limestone can be replaced with supplementary materials such as fly ash and slag, which are basically byproducts of other industries. This can actually reduce its carbon emitting potential. The challenges with this is that dependent on other industries, which can become redundant in the future because of transition to renewable source of energy. Also, there's a limit to which how much cement clinker can be replaced, as this can affect the strength of the concrete itself. Building codes usually provide a restriction on this. There are better long-term alternatives for a country like India, for example using blended cements like LC3 or limestone calcite clay cement. These are locally available low-grade limestone and clay. Personally, since I'm part of the building industry, I can take a more proactive role in spreading awareness among stakeholders, builders, and even the government policy. It's necessary to challenge the demand and intent of builders. Questions like, is it necessary to build a new structure? Is it possible to refurbish an old building? These kind of questions are necessary. If there is absolutely no choice but to build, then it's imperative to build cleverly and efficiently as possible. For example, using low carbon materials. This reverse pyramid here actually captures the philosophy to be used. Thank you.